So now let us try and understand the process of getting the theoretical yields of reactions or from reactions and percent yield. So these are examples of finding the theoretical yield and percent yield, and I'm going to use one question and show you how to do it, probably using method 1 and using method 3. I prefer method 1 because the same process of finding what we call the limiting reactant or limiting reagent is going to be the same process that's going to give me the theoretical yield. This is like killing two birds with one stone. Hey, it's your cup of tea. You decide how you're going to take it. For me, I'm taking it as method 1, preferably, but I'll show you both. So, like I mentioned, we have to find the limiting reagent before we find theoretical yield and use that to find percent yield. Okay, now before I read the question, let me give you the formula of percent yield. Percent yield is always equal to actual yield over theoretical yield, and I'm going to multiply that by 100. Now you see why I prefer method 1 of finding the limiting reactant. So let's dive into the question. Question: 12 grams of CO2 reacts with 8 grams of water to give you 7.5 grams of a carbohydrate, probably glucose. Determine the percent yield of glucose from this reaction. The reaction itself is given here and it's already balanced for you. If you want, you can confirm, but it is balanced as I've confirmed it. Step 1, we need to find the limiting reagent, and in this case I'm going to show you using method 1 as typed on the top left, this method. So what is method 1 of finding the limiting reagent? Separately calculate the amount of product that could form from each reagent. The reactant that produces the smaller amount of product is limiting. So let's find the reagent that will produce the least amount of product. Is it CO2 or water? That is the reagent side or reactant side. That's where the limiting reagent will come from. So let's do this. We are separately going to calculate the amount of product, which most likely is going to be the theoretical yield that could form, or the maximum amount of product that could form from each reactant. So let's test CO2. Question: is CO2 going to be completely consumed? That's the definition of limiting reagent or limiting reactant. The limiting reagent is the one that's going to be completely consumed. So we need to answer that question using method 1. To do so, I'm told that I have 12 grams of CO2 and I need to find how much glucose possibly is going to be made. Okay, so now the plan here is to go from grams of CO2 to moles of CO2. Then I can now find the moles of the glucose, because moles and moles relate based on the chemical reaction mole ratio. And then from there, if I really want to get the yield, I can find the yield in grams of glucose. Okay, the theoretical yield in grams of glucose if CO2 was limiting. Now this process or this plan is going to help us to quickly finish the calculation, but let's first find the molar mass of CO2. Molar mass of CO2 is going to be equal to the mass of carbon plus the mass of 2 oxygens, and that's going to be equal to the mass of carbon. If you look at the periodic table, is supposed to be about 12. Let's go to the periodic table and see. Carbon is right here. The mass of carbon is 12.011. The atomic mass of oxygen is 15.999. And the atomic mass of hydrogen is 1.008. We need all those numbers to find molar masses of CO2 and glucose. So atomic mass of carbon is 12.011. Atomic mass of each oxygen is 15.999. If you sum these up, the molar mass of CO2 will be 44.009 grams per mole. So the molar mass of CO2 is 44.009 grams per mole. And again, before we go far, we also need the molar mass of the glucose, because we have to convert grams to moles to grams, glucose. So for glucose, we'll have to multiply 6 times molar mass, atomic mass of carbon, plus 12 times atomic mass of hydrogen, plus 6 times atomic mass of oxygens, the 6 oxygens. And that is going to be 6 times 12.01111 for each carbon from the periodic table, 12 times 1.008 for each hydrogen from the periodic table, then 6 times 15.999 atomic mass of oxygen. All this is in grams. If I sum these up, the molar mass of glucose will be 180.156 grams per mole. So each mole of glucose weighs that much grams. So we needed to get these molar masses so we can execute our plan. Remember, our plan is to convert grams of CO2 given in the question. We are given 12 grams of CO2 to moles of CO2. Then using the reacting mole ratio in the chemical reaction, we'll find moles of glucose. Then we convert that to grams of glucose. So let's see, if CO2 is limiting, what is the actual product amount, which is glucose amount. So we're going to write the dimension analysis, 12 grams of CO2. We're going to multiply it by the first conversion factor. Every 1 mole of CO2, remember we want to get to the mole of CO2, is equivalent to its molar mass, 44.009 grams per mole. That is conversion factor 1. And then we go to conversion factor 2, CF2. Based on the chemical reaction, I see that 6 CO2s reacts with 6 waters to give you one glucose and 6 moles of oxygens. This is photosynthesis, so oxygen is made. Oxygen is released from the leaves. So the reacting ratio between CO2 and glucose is 6:1. Or 1:6. So for every 1 mole of our product, which is glucose, we reacted 6 moles of CO2. Okay, and then now we are ready for the next conversion factor. Conversion factor 3, we want to go from moles of glucose to grams of glucose. So I'll use the molar mass of glucose, 180.156, this, which is why we needed to calculate it. Grams of glucose is actually 1 mole of the same glucose. So doing this way, we are going to get the answer in grams of glucose. Using method 1, once I test CO2 to see if it's limiting, I'll also test water to see if it's limiting. Whoever will give us the least amount of glucose in grams will be the limiting reagent, either CO2 or water. The limiting reagent is always one of the reactants. So let me do the math and then tell you what I get. You can do it too. So the answer I'm getting, if CO2 was limiting, the amount of glucose to be formed would be 8.187 grams. if and only if the CO2 carbon dioxide was a limiting reagent, meaning if all CO2 is going to be consumed in this photosynthetic reaction. So we are going to go to test 2. Test if water is limiting. How much glucose is formed? So we do the same thing. Our plan is similar. If you read the question, it says 12 grams of CO2 reacts with 8 grams of water to give you 7.5 grams of glucose. Actually, this 7.5 grams is your actual yield. It's what was actually made. What you're trying to look for here is the limiting reagent plus the theoretical, and then we'll use our formula for percent yield, which is actual over theoretical times 100. So you see we are given the reagent water as mass or in mass as 8 grams. So we are going to flow with the same process. We're going to go from grams of H2O, convert it to moles of H2O, then convert that to moles of product, which is our glucose, then convert that to grams of product, which is our glucose, to see how much grams can be theoretically made if water was limiting. If water gives us the least grams of glucose lower than 8.17, then water is limiting. If CO2 gives us 8.17 as the least mass compared to what water is going to give us, then CO2 is limiting. So that's why we are testing for water just as we tested for CO2. So now remember that we need the molar mass. The molar mass of water is just going to be H plus H plus O. The mass of hydrogen is 1.008 multiplied by 2. And then add the molar mass of oxygen, which is 15.999. If I add all those up, I get 18.015 grams. That's the molar mass of water. So since we started with 8 grams of water from the question, I want to use the first conversion factor, let's call it CF1, to get it to moles. So I'll say 1 mole of H2O is actually 18.15 grams. It weighs that much. Then once that is done, I do the second conversion factor. I need moles of water to moles of glucose. So that one I'll have to run to the balanced chemical equation. I see for every 6 moles of water, I make 1 glucose. So I'll say 1 mole of glucose from our balanced chemical equation of reaction always is yielded once we react 6 moles of H2O. Now, so far, grams of water will cancel. Then you'll see here moles of water will cancel. Our answer here will read, after punching in the numbers, it will be X moles of glucose, C6H12O6. But we want our answer in grams of glucose. So we use our third conversion factor, CF3. So we'll say 180, which is the molar mass we calculated before, 180.156 grams of glucose, C6H12O6, is actually 1 mole of itself. Why do we need that conversion factor? Because we want to get rid of the moles of glucose, and what our answer will read in is going to be in grams of glucose. Whatever our answer will be, it's going to be in grams of glucose. So let me do the math, see what we get. So I'm getting 13.332 grams of glucose if water is limiting. Now go back to the rule for method 1 of finding the limiting reagent. I'll erase, then we read again. So method 1 of finding the limiting reagent is separately calculate the amount of product that could form from each reactant. The reactant that produces the smaller amount is limiting. So these are the amounts of products from the 2 molecules. We've calculated them separately to determine their possible amount of products. if they were limiting, if they were calling the shots, if they were completely consumed. So between these two, who gives us the least amount of glucose? Is it the CO2 or is it the water? I see I have 8 grams approximately, I have 13 grams. So the CO2 is limiting because it gives us the least amount of product. Now, that amount is also the theoretical yield. So CO2 gives the least amount of product. We are talking about 8.187 grams. Therefore, we can conclude that 8.187 grams is the maximum possible yield from this reaction, and we are going to call it is the theoretical yield. So now we can find our percent yield. Percent yield is always the actual yield divided by the theoretical yield and times 100. What is our actual yield? The question reads 12.0 grams of CO2 reacts with 8 grams of water to give 7.5 grams of glucose. Okay, so our actual yield is gonna be the 7.5. It's gonna be, so our actual yield is gonna be the 7.5 grams of glucose. Okay, so we'll come here and just put the 7.5 grams here. That's our actual. Our theoretical is what came from our limiting reagent, the CO2. The least amount that we could get from one of the reagents was 8.3187, and the reagent that enabled us to get the least amount was CO2. So CO2 is the limiting reagent. Then multiply by 100. I'm getting 91.61%. The question has the values given in 3 significant figures, so this in 3 sig figs will be 91.6%. So we found the theoretical yield, which was 8.187 from the limiting reactant. This theoretical yield was from CO2, the limiting reagent LR. That is one goal we've succeeded to do, to find the theoretical yield. And now we've found the percent yield using the theoretical yield given the actual yield in the question. The percent yield was 91.96. So that is the method 1 way of doing this. We are going now to use method 3 of finding the limiting reactant. To find the limiting reactant, we are going to find the amount of each reactant needed to completely use up the other. You are going to disregard the scenario that requires more of a reactant than is actually present. The main point here is to find the amount of each reactant needed to completely use up the other. So you're focusing just on the reactants, the CO2 and the water. So let's read the question here and then we'll strategize. Question: 12 grams of CO2 react with 8 grams of water to give 7.5 grams of glucose, C6H12O6. Determine the percent yield of glucose from this reaction. And I'll have you know that we'll really have to find first the limiting reagent and then use the limiting reagent to find the theoretical yield, and then use the theoretical yield to find the percent yield. Okay, so now let's use method 3 of finding the limiting reagent, where we find the amount of each reactant needed to completely use up the other reactant. So let's ask ourselves question number 1. How much CO2 is needed to completely react with H2O? So in this reaction where CO2 is reacting with H2O to give you glucose and oxygen, I'm suspecting this is going to be photosynthesis. Okay, this is photosynthesis happening in the leaf, where the leaf takes in the CO2 and gives us oxygen. So how much CO2 is required to completely consume H2O? So this is what we are going to do. In this case, step number 1, we'll have to find the moles of both of them. What is the moles of water? We already did the molar mass of water. So to find the moles of water, is going to be the grams given of the water multiplied by the mole formula weight relationship. The mole formula weight relationship, 1 mole of water is really 18.015 grams. We did this before. And that's going to give us the moles of water to be, let's bring up the calculator. Okay, 8 divided by 18.015. So I'm getting 0.444 moles about. Let's say 441 moles of water. So the 8 grams is really this much moles. And then let's find moles of CO2. So moles of CO2 is 12 grams of CO2. We're going to multiply it by its mole formula weight relationship. 1 mole of CO2 is equivalent to what mass? Let's find CO2. We found the molar mass of CO2 is 44.009. We did that before. We took time to do that. This way, grams of CO2 will go. The answer is in moles of CO2. So I'll say 12 divided by 44.009, and the answer is 0.27267 moles of CO2. So this is just telling us that the 12 grams of CO2 is this much moles of CO2. We needed those values in moles so that we can do the math. Now we go back to the original question, how much CO2 is needed to completely react with water? Now you can see in the reacting ratio, it is 6 moles of CO2 reacting with 6 moles of water in the balanced equation. So if I need to find how much CO2 is needed to completely react with water, this is what I do. I take my moles of water, which is 0.4441 moles of water, and I multiply it by the mole ratio. For every 6 mole of CO2 in our balanced equation, we need 6 moles of water from our balanced equation. 6 and 6 will cancel, moles of water will cancel, so we will need this much moles of CO2 to completely use up all the water. So that was test 1. Test 2, we are going to ask ourselves a similar question. How much water is needed to completely react with CO2? All this we are doing is to find who is the limiting reagent before we can find the theoretical yield. Okay? So we already know the moles of water and CO2. So in this case, I'll start with the moles of CO2 because you're going to the moles of water. So I'll say 0.27267 moles of CO2, which is what we calculated right here, where I'm highlighting in green currently. Okay, in this step right here, we found these moles of CO2. 0.27267 moles of CO2. We are going to multiply it by the conversion factor for every 6 moles of water, because that's where we are going. You need 6 moles of CO2. This will help us to cancel out moles of CO2. Our answer will be in moles of water. Remember, we are asking how much water is needed to completely react with CO2. And it turns out to be 0.27267 moles of water. Now look at these two. If you want to completely react water with CO2, this is the much CO2 you need right there. If you want to completely react CO2 with water, this is the much water you need. So which one of these do you think is limiting? We are going to go and check what we were given. Okay, so what we are given in this problem is the amounts of CO2 and water originally. So we are starting with 0 originally. So let's decide. Originally, we were given 8 grams of H2O, which turned out to be 0.441 moles. Okay, and then we are also given 12 grams of CO2, which is equivalent to 27267 moles. Now look at what we found out. How much CO2 is needed to completely react with water? We need 0.441 moles of CO2 to completely react with water. Do we have that much CO2 from the original amount? Do we have that much CO2? We need 0.4441 moles of CO2 to completely react with water. Yet we only have 0.27. And in the second case, how much water is needed to completely react with CO2? We just need 0.27267. Yet originally we have 0.4. We have more than enough water than compared to CO2. Our calculation says that we need 0.441 of CO2 to completely react with water. So CO2 is our limiting reagent. Okay, it's 2 less. So once we find who is the limiting reagent, now we can go and find a theoretical yield. Let's do that. The limiting reagent is CO2. The original amount of CO2 is 27267. That's what we're going to go with our calculations. So conclusion is, we now know, according to method 3, CO2 is the limiting reagent. So next, we need to find the theoretical yield. Now you see why I was telling you that I prefer method 1. I found the limiting reagent as CO2. At the same time, I found the theoretical yield. I found the theoretical yield to be 8.187. So I killed 2 birds with 1 stone, according to method 1. But now with method 2, I've firstly had to find who is the limiting reagent, finish. Then start calculations again. And now next, we're now going to find the theoretical yield. So to find the theoretical yield, we are going to go from the moles of CO2 that we've calculated. This one has been calculated already. And then from there, we'll take it to moles of our product, C6H12O6. We need to know in theory how much we should make, how much glucose we should make, how much C6H12O6 we should make if there's no errors in the reaction. And then we'll convert that to grams of the product of glucose, which is C6H12O6. So from our calculations, previous calculations, we knew that the limiting reagent was CO2, and it was provided as 12 grams, which we converted to moles to be 0.27267, and that moles is what we're going to bring in our calculations here. So moles of CO2 was 0.27267 moles. we need our first conversion factor to go to moles of the product. You will look here, for every 6 moles of CO2, we are making 1 mole of glucose. So it's 6 to 1 or 1 to 6. So for every 1 mole of product, which is where we are going, C6H12O6, we must react 6 moles of CO2. That is our first conversion factor right there. Now, to this point, it will help us to cancel the moles of CO2, and the answer will be X moles of C6H12O6, the glucose. Now we need the second conversion factor here. We already calculated the formula mass of glucose to be 180 point. We took the time and calculated the molar mass of glucose. The molar mass of glucose, we did it here. This process right here was 180.156. 180.156 grams is going for 1 mole of glucose. So for every 180.156 grams of glucose, we call it 1 mole of the glucose. This will help us to cancel moles of glucose and moles of glucose in writing in this way, using this conversion factor 2. All is left is to do the math. The answer should read Y grams of glucose, and that is gonna be our theoretical yield. Remember again, the theoretical yield is calculated from our limiting reagent or limiting reactant, which we determined before, it's CO2. So that's why we are using the moles of CO2 right here. Okay, this right here was moles of CO2. So the answer we'll get here will be the theoretical yield based off limiting reactant CO2. That means in theory, this is the much glucose you should make, or the reaction should make, if there are no errors. Let me do the math. So the answer I'm getting as a theoretical yield is 8.18719 grams of glucose as a theoretical yield. So if you want to find the percent yield, which was the question, see, the question reads 12 grams of CO2 reacts with 8 grams of water to give you 7.5 grams of glucose. Determine the percent yield of glucose from this reaction given the equation of reaction. If you want to find the percent yield of glucose, C6H12O6 is going to be equal to the actual yield, is given in the question, divided by the theoretical yield. We multiply by 100. This 7.50 grams of C6H12O6 is actually the actual yield. How do I know that? Because the question tells me. It tells me 12 grams of CO2 reacts with 8 grams of water to yield 7.5 grams of glucose. So I'll take the 7.5 and put it here. The theoretical yield, we have already calculated the theoretical yield here, and it's 8.1871 grams. We multiply by 100. So I do 7.5 divided by 8.18719 equals 2 times 100. The answer I'm getting is 91.77, approximately 91.8%. If you use 8.19 here, the answer will be approximately 91.6, which is similar to what we got earlier, down here. So I've shown you 2 ways of finding the limiting reagent that takes you to the same answer. Which theoretical yield will I use? I'll use this one that is not rounded so much to give me 91.8. So that's how you do this. Whichever method you want to follow, it's your choice. whether you find the limiting reagent by method 1 or method 3. For me, I prefer method 1 because it gives me both the limiting reagent and the theoretical yield. Then I can just complete my question to find the percent yield. Question wanted us to determine the percent yield of glucose. That's it. Practice.